Dear students, in this video we are going to discuss about the previous year Anna University question, and the topic is design a digital Chebyshev filter. But the given problem they have not mentioned what is the filter, but we should know based on the given data we have to find which type of filter or which type of digital filter they have asked. For that you have to read the problem very carefully. Design a digital filter which exhibits equiripple behavior only in either passband or stopband and monotonic characteristics in either passband or stopband. The important hint is if the filter is monotonic in passband and stopband, then it is Butterworth filter. Butterworth filter. This is first point. Second point, if the filter is monotonic in either passband or stopband, then it is Chebyshev filter. Based on the given question, it is monotonic characteristics. It exhibits monotonic characteristics in either passband or stopband. So this problem comes under Chebyshev filter. And they given the important format of the Chebyshev filter. This is the very famous format. University question normally comes under this format. This is the general university question format. You have to learn 1 by root of 1 plus epsilon square less than or equal to modulus of e power j omega less than or equal to 1 from 0 to omega p. This is the passband gap. Next, modulus of which of e power j omega less than or equal to 1 by root of 1 plus lambda square from omega s to pi. This is the stop band limit. In this place omega s and in this place omega p. If you match with the given question, omega p equal to 0.2 pi and omega s is equal to 0.65. Similarly, 1 by root of 1 plus epsilon square is 0.8 and 1 by root of 1 plus lambda square is 0.2. If you study this university question format, then only you can match with the given problem to find epsilon value, lambda value, omega p value and also omega s value. Otherwise, you cannot take the given data from the problem. So first of all, we have identified what is the type of the filter. Based on the data, we identified the given problem comes under Chebyshev filter. Then we compared with the university question format to get the values of omega p and to get the values of omega s. Then we have matched 1 by root of 1 plus epsilon square with this 0.8 and 1 by root of 1 plus lambda square with this 0.2. Normally, every digital filter, it may be a Butterworth filter or it may be a Chebyshev filter. It may be using impulse invariant method or it may be using bilinear transformation. So, every digital filter design have 3 levels. In the first level, we are going to convert the digital frequency small omega, this is small omega, into analog frequency capital omega. To convert this digital frequency small omega into analog frequency capital omega, we have two formula. One is capital omega equal to small omega into t and another one is capital omega equal to 2 by t tan omega by 2. Which formula we have to use? That depends upon the method they have mentioned in the given problem. In the given problem, they have mentioned bilinear transformation. For bilinear transformation, you should not use this formula. You have to use this formula. Capital omega equal to 2 by t tan omega by 2. We already know the value of omega p. Omega p is equal to 0.2 pi and omega s is equal to 0.6 pi. From this small omega p, I should find capital omega p using this formula. Why I am using this formula? This method is bilinear transformation method, so I should use this formula. If the given problem is impulse invariant method, then I have to go the formula capital omega equal to small omega t. Now I am going to use capital omega is equal to 2 by t tan omega by 2. To get omega p, I need to convert this small omega into small omega p. So 2 by t is 1 given in the problem, tan omega p by 2, which is equal to 2 tan omega p, we know 0.2 pi divided by 2. Now you can use the calculator fx 991 ms. The answer is 0.6498, but keep in mind the calculator should be in radian mode. That is very, very important. You cannot keep the calculator in degree mode. To make it in radian mode, you should use mode button 4 times and select radian. The option is 2. The option will be changed to radian. So after setting in the radian mode, if you use 2 tan 0.2 pi by 2, then you will get the answer 0.6498. Then I need to find omega s. This is capital omega p. Now I need to find capital omega s. For that I have to use s here, small omega s. Capital omega s is equal to 2 by t tan small omega s by 2. Now substitute the values. 2 by t value is 1, tan omega s is 0.6 pi by 2. Now use the calculator. You will get 2.7527. Now we got capital omega p is ready and capital omega s is ready. So level 1 over. We have successfully completed level 1. Okay. In level 1, we have converted a small omega into capital omega. That is digital frequency into analog frequency. In the level 2, we are going to design the filter. Now, which filter they have asked? Indirectly, they have asked the Chebyshev filter. So, we are going to calculate the design of Chebyshev filter. We have 5 formula to design the Chebyshev filter. While doing the level 2, we need to consider which type of filter. We no need to find which is the method, whether it is bilinear transformation or impulse variant. You no need to consider the method. You need to design the filter. Whatever may be the filter, you design the particular filter. Here in this problem, they have asked Chebyshev filter. Now I am going to do the 5 steps of this Chebyshev filter. Step 1, to find the value of n. N formula, n is equal to cos h inverse of lambda by epsilon divided by cos h inverse of omega s by omega p. This omega s and omega p we have already found in the level 1. Now we need lambda and epsilon values. To get lambda value and epsilon value, you need to match the given problem with the university question format. If you match the given problem and this format, then you will get 1 by root of 1 plus lambda square is equal to 0.2 and 1 by root of 1 plus epsilon square is equal to 0.8. After matching the given problem with university question format, I got 2 terms. One is 1 by root of 1 plus epsilon square is equal to 0.8 and another one is 1 by root of 1 plus lambda square is equal to 0.2. From this data, we have to find this epsilon and this lambda value. For that I need to take inverse, reciprocal of this term. Root of 1 plus epsilon square is equal to 1 by 0.8. Squaring on both sides, 1 plus epsilon square is equal to 1 by 0.8 the whole square. Epsilon square is equal to 1 by 0.8 the whole square, plus 1 becomes minus 1. Epsilon square is equal to, use calculator, you will get 0.5625. Take root of 0.5625. So epsilon is equal to 0.75. The same steps you have to do for this side also. 1 by root of 1 plus lambda square is equal to 0.2. Taking reciprocal, root of 1 plus lambda square is equal to 1 by 0.2. Squaring on both sides, 1 plus lambda square is equal to 1 by 0.2 the whole square. Lambda square is equal to 1 by 0.2 the whole square. This plus 1 becomes minus 1. Lambda square is equal to, if you use calculator, you will get 24. If lambda square is equal to 24, therefore lambda equal to root of 24. Using calculator, we get lambda equal to 4.898. Now substitute lambda value, epsilon value, omega s, omega p. These values are obtained in level 1. Substitute all the values in this n formula. You will get cos h inverse of 4.898 divided by 0.75, the whole divided by cos h inverse of 2.7527 divided by 0.6498. Again you have to use the calculator. fx991 ms. First on the calculator and put the mode HOP. HOP mode. HOP will be in the middle of the calculator, just below the x square button, just below the x square button. On the HOP button and put shift plus cos button. Shift plus cos gives cos h inverse. You will get cos h inverse, and then use the bracket, and you can type like this: cos h inverse of 4.898 divided by 0.75, the whole divided by, again cos h inverse. You have to follow the same procedure. No need to put on, just on the HOP button and press the shift and cos button in the same time. You will get, again you will get cos h inverse. Now you type 2.7527 divided by 0.6498. Put the equal to button. You will get 1.207. Approximately you will get 1.207. Next step 2. In this step, round off n value to the next nearest integer. You have to round off the n value obtained in step 1 to round off. That is, if you got 1.207, you have to round off to the next nearest integer. Next integer means you have to use 2 here. So whatever may be, maybe 1.12 or 1.13 or 1.75, whatever may be. If the answer in the step 1 is 1 point something, then in the second step you have to round off to the next integer value, that is 2. If the answer in the step 1 will be 2.1 or 2.2 or 2.3 something, means you have to round off to next nearest integer, that is n is equal to 3. Next step 3. In this step we have to find the values of small a and small b using the formula a equal to omega p mu power 1 by n minus mu power minus 1 by n by 2. B is equal to omega p mu power 1 by n plus mu power minus 1 by n divided by 2, where this mu can be obtained using the formula mu equal to epsilon inverse plus root of 1 plus epsilon power minus 2. In the formula of a and b, except mu, we know all the values. Omega p, n we already know. So first you need to find the mu value, then you can easily find the values of a and b. As we know, the mu value can be obtained by epsilon inverse plus root of 1 plus epsilon power minus 2. We know the value of epsilon is 0.75. So 0.75 inverse plus root of 1 plus 0.75 power minus 2. Again we are using calculator. Calculator, how to use? First you have to type 0.75 power minus 1. You have a symbol, cap symbol to put the power. So power minus 1 plus root of. So whenever you use the root, you need to put a bracket. So after putting a bracket, type 1 plus 0.75 power, again the cap symbol, power minus 2, and close the bracket, type equal to symbol, you will get 3. Now substitute all the values in A formula. So A equal to 0.6498 mu power 1 by n, n value is 2, minus mu power minus 1 by n, n value is 2, the whole divided by 2. If you use calculator, you will get 0.375. If you substitute in B, you will get 0.6498 into 3 power 1 by n, n value is 2, plus this minus will be plus 3 power minus 1 by n, n is equal to 2 by 2. Then you will get, if you use the calculator, then you will get 0.7503. In this calculation, while using calculator, when you type 3 power 1 by 2, you have to type 3 power, in the bracket only you have to type 1 by 2. Here also 3 power bracket open minus 1 by 2. Otherwise error will come or wrong answers will become. Next, step 4. In this step, we are going to find the denominator of h of s using the poles sk equal to a cos phi k plus jb sin phi k, where k ranges from 1 to n. Here n is equal to 2, so k will be 1 and 2. If n is equal to 3, then k will be 1, 2, 3. Now the n value is 2. The order is 2, which is obtained in the step 1 and step 2. We got n is equal to 2. So you need S1, S2. For that you need phi 1, phi 2. Before that you substitute A and B in the SK formula. So SK equal to 0.375 cos phi k plus J 0.7503 sin phi k, where phi k equal to pi by 2 plus 2k minus 1 into pi by 2n. Since n is equal to 2, you need phi 1 and phi 2 only. From phi 1 and phi 2, you will get S1 and S2 using this formula. So now phi 1 means you have to substitute k is equal to 1. K is equal to 1. Phi 1 is equal to pi by 2 plus 2 into 1 is 2, 2 minus 1 is 1, 1 into pi divided by 2 into 2 becomes 4. Now LCM is 4. This is 2 pi, this is pi. You will get 3 pi by 4. Next, you have to substitute k is equal to 2. Then phi 2 equal to pi by 2 plus 2 to 4, 4 minus 1, 3, 3 pi by 4. Take LCM 4, 2 pi plus 3 pi, you will get 5 pi by 4. Now you got phi 1 and phi 2. Next, we can find S1 and S2. If you substitute k equal to 1, then you will get S1 is equal to 0.375 cos phi 1 plus j 0.7503 sin phi 1. We already know the values of value of phi 1. So you will get 0.375 cos 3 pi by 4 plus j 0.7503 sin 3 pi by 4. Just you have to type in the calculator. How? This is calculator screen. You need to type 0.375. Before that, you have to type j here. So you need to on the calculator mode button one time. You will get two modes. One is compound mode and another one is complex mode. Compound mode means you should select 1. Complex means you should select 2. So the calculator should be in the complex mode. So you need to type 2. After pressing the mode button once, you need to select the complex by pressing the number 2. So the calculator will be in the complex mode. After that, you can type 0.375 cos. Before that, it should be in the radian mode. We already know that whenever you are doing Chebyshev filter or Butterworth filter using Bilinear transformation or impulse invariant method, using our method, you can always keep the calculator in the radian mode because we are using pi in the calculation. So always the calculator will be in the radian mode. So 0.375 cos bracket open 3 pi by 4 bracket close plus. Again, very important point is this j, whenever we write, we always put the j before the number. But if you use calculator, then you should write this calculator here. Whenever you are using calculator, you should type like this 0.7503, then only you can type j. Sin bracket open 3 pi by 4. Now you can put the equal to button. You will get minus 0.265 only. But keep in mind, there will be an imaginary part which is not shown by our calculator. To get the imaginary value, you need to press the shift button and then press the equal to button. Shift button and then equal to button, you will get the imaginary part as 0.5305 I. The calculator is showing the imaginary part as I. But in the case of the calculation, we use j here. So you are getting minus 0.265 plus 0.5305 j. This is the value of S1. Then you need S2. For S2, you need to type 2 here. 0.375 cos phi 2 plus j 0.7503 sin phi 2. You replace the phi 1 as phi 2. So automatically 3 pi by 4 becomes 5 pi by 4. This 3 pi by 4 is also becomes 5 pi by 4. While doing in a calculator is also, you can replace this 3 by 5. This 3 also replaced by 5. Now put the equal to button. You will get again minus 0.265. You will not get any imaginary part here. To know the imaginary part, you should press the shift button and then the equal to button. The same procedure how we got this imaginary part, like this only. You are typing the shift button and equal to button. Now you will get minus 0.5305 I. The I will be here written as j. So now we got all the poles. Because n is equal to 2, you are getting only 2 poles. For n is equal to 3, you need to find S1, S2, S3. For that, you should find phi 1, phi 2, phi 3. From phi 1, phi 2, phi 3, you can easily get S1, S2, S3 in the case of n equal to 3. For n equal to 4, you need to find S1, S2, S3, S4. For that, you need to find phi 1, phi 2, phi 3, phi 4. Now there is no problem. In our problem, we got n is equal to 2, so we need only S1, S2. From this S1, S2, we are going to find the denominator part of the answer, denominator part of the transfer function. That is, denominator is equal to S minus S1 into S minus S2. If n is equal to 3, you will get S minus S3. If n is equal to 4, then you will get S minus S4. But in this problem, we need only S1 and S2. So the denominator formula will be S minus S1 and S minus S2. You no need these two terms. Now substitute the values of S1 and S2. S minus S1 value minus 0.265 plus 0.5305J. This is S minus S1. S minus S2 will be minus 0.265 minus 0.5305J. Then bring this minus inside. So you will get S plus 0.265 minus 0.5305J. The second term also S plus 0.265 plus 0.5305J. Separate the real part. Separate the real part. So these are the real parts and these are the imaginary parts, and these two terms are like A minus B, A plus B. So the next step will be A plus B into A minus B, A square minus B square. So S plus 0.265 square minus B square means 0.5305 square J square. Next step, you can use A plus B the whole square formula. A is S and B is 0.265. A square plus 2AB plus B square means 0.265 square. We already know J square value is minus 1. So this minus becomes plus. J square is minus 1. That minus 1 combines with this minus, we get plus. Also we have 0.5305 square. S square plus, if you multiply this 2 and 0.265, you will get 0.53S plus, if you use calculator for these two terms, you will get 0.3516. This is the denominator part of the H of S, or denominator part of the level 2. Next is step 5. In step 5, we have two formula to find the numerator of H of S. If n is odd, then numerator can be obtained by just substituting S is equal to 0 in the denominator. Just substitute S is equal to 0 in the denominator, which is obtained in the step 4. Previous step we got the denominator. Just put S is equal to 0 in that denominator, the obtained value will be the numerator. But this is only in the case if n is odd. If n is even, then numerator can be obtained by substitute S is equal to 0 in denominator and divide the total value by root of 1 plus epsilon square. Which formula we need to use this problem? Here n is 2, which is a even number, so we go for this second formula to find the numerator because our n is even. Here n is even, so numerator is equal to, substitute S is equal to 0 in denominator. So if you substitute S is equal to 0 in this denominator, you will get 0 plus 0 plus, yes, here also you have S, here also you have S, you will get 0 plus 0.3516, and then divide the total value by root of 1 plus epsilon square. We already know the epsilon value is 0.75. So 0.75 square. Now you can use calculator. 0.2813. Here also, whenever use root, you have to use the bracket. While typing in calculator, you should use bracket after the root symbol. Otherwise, you will not get the correct answer. So, in this problem, we got the numerator and also the denominator. Therefore, in level 2, the final answer will be numerator by denominator. So 0.2813 the whole divided by s square plus 0.53s plus 0.3516 will be the final answer of level 2, but we need to do the level 3, don't forget. Here the calculated h of s in level 2 is the analog transfer function, but we need digital transfer function. So in level 3 you need to consider what is the method. Here the given method is bilinear transformation. So by using this bilinear transformation, you need to convert this analog transfer function h of s into the digital transfer function or digital system function h of z. So if you go through the procedure, in level 1 you are converting the digital frequency into analog frequency, that is small omega into capital omega. In level 2 you are designing the filter. In level 3 again you are converting the analog into digital. Analog, that is h of s, into digital, that is h of z. This is a very important sequence. Digital into analog, and we are designing the filter with the analog data. After that we are converting the analog transfer function obtained in the level 2 into the digital transfer function h of z. To convert this, for this conversion and this conversion, you need to know which kind of method was given. In this problem they have mentioned bilinear transformation, otherwise they will mention impulse invariant method, but in this problem they have mentioned bilinear transformation. But in level 2 we need to consider which is the filter has to be designed. In this problem they have asked Chebyshev filter indirectly, so in the level 2 we have designed the Chebyshev filter, and in level 1 and level 3 we have used the bilinear transformation procedure. To convert h of s into h of z using bilinear transformation, you have to substitute s is equal to 2 by t 1 minus z inverse divided by 1 plus z inverse. Directly you can substitute the value of s into 2 by t 1 minus z inverse divided by 1 plus z inverse. This is the obtained transfer function in level 2. We are substituting s tends to 2 by t 1 minus z inverse divided by 1 plus z inverse. We already know the value of t is 1. So 2 into 1 minus z inverse divided by 1 plus z inverse. So the next step will be h of z is equal to, we are converting using this relation, we are converting h of s into h of z, 0.2813 the whole divided by s square. S square means I need to substitute s tends to this 2 into 1 minus z inverse divided by 1 plus z inverse. For s square, 2 becomes 4, 1 minus z inverse becomes 1 minus z inverse square, this 1 plus z inverse becomes 1 plus z inverse square, plus 0.53, this is 0.53. Again yes, for yes you need to substitute 2 into 1 minus z inverse divided by 1 plus z inverse, plus you have 0.3516. This is the last step I was written in the previous page. Now in the denominator you can take LCM. The LCM is 1 plus z inverse the whole square. Now you can directly write the numerator 4 into 1 minus z inverse the whole square. In this you have only 1 plus z inverse, so the numerator will be multiplied by 1 plus z inverse. So you will get, multiplying this you will get 1.06. There you have 1 minus z inverse, you need to put another 1 plus z inverse. In this denominator you don't have any terms, so you need to multiply with the LCM. 1 plus z inverse the whole square. Bring this denominator into numerator, so you will get 0.2813 1 plus z inverse the whole square, the whole divided by 4 into, expanding this using a minus b the whole square, a square minus 2ab plus b square plus 1.06. Here also a plus b, a minus b, a plus b, a minus b. So you will get a square minus b square. B square means z inverse square. Z inverse square means z power minus 2. Here also you should use the a plus b the whole square formula. So you will get 0.3516 into a square plus 2ab plus b square. In the next step, I am not disturbing the numerator term. The denominator should be expanded. Clearing the brackets, I will get 4 minus 8 z inverse plus 4 z power minus 2 plus 1.06 minus 1.06 z power minus 2 plus 0.3516 plus 0.7032 z power minus 1 plus 0.35 z power minus 2. What I did is just multiplying these terms, that is clearing the brackets. I am getting the values. I am removing the brackets. In this step you can also expand the numerator term using a plus b the whole square. Using a plus b the whole square formula, I can easily expand as 1 plus, that is a square minus 2ab plus b square. But it is your wish. You can expand or you may not be expand the term. You can simply keep that term as such. In the next step, h of z is equal to, I am multiplying the 0.283 inside, 0.2813 plus 0.5626 z inverse, I am multiplying these two terms, plus 0.2813 z power minus 2. In the denominator also, you can add the like terms. Like terms means these numbers can be added. This 4, this 1.06, this 0.3516 can be added. If I add these terms, I will get 5.4116. Also I can add these terms, these z inverse terms, that is this minus 8 z inverse and 0.7032 z inverse. I will get minus 7.2968 z inverse. Again I can add this z power minus 2 terms. If I add these 3 terms, I will get plus 3.2916 z power minus 2. If you do up to this step, you will get the full mark. There is no problem. This is the final answer. But in some books, they will make this term into 1. This is the universally acceptable format. They need this term as 1. So you can divide all the terms, all the coefficient terms by this 5.4116. If you divide all these terms into 5.4116, this term becomes 1. So it is a universally acceptable form. So we can do this step also. But in the case of university examination, you can stop up to this step. If I divide all the terms by 5.4116, I will get h of z is equal to 0.0519 plus 0.1039 z inverse plus 0.0519 z power minus 2 the whole divided by 1 minus 1.348 z inverse plus 0.6082 z power minus 2. Just use calculator to divide the values. Divide the values by 5.4116. This term, this term, this term, every coefficient term will be divided by this 5.4116 to get the final answer as a universally acceptable form, that is, this term must be 1. Thank you.